online. I hope that works. So good morning, everyone, to our last day of the summer school. Almost a bit nostalgic. I'm delighted to present you today Michael Franke, who will talk about pragmatics and relevance in conversation. So it's one of our language speakers. We had already Lars Meyer on Monday, who talked a little bit more about the biological language models. We had Ethan Paris on Wednesday talking about large language models. And maybe this is a bit more in between, like Bayesian modeling of language now. So Michael is a professor at the Department of Linguistics here in Tübingen, and has great work on modeling linguistics in Bayesian ways with speakers and listeners trying to understand each other. And without further ado, I will give the mic to him. Stage is yours. Thanks a lot.
Thank you very much for the kind introduction. Thanks for being here. Thanks for organizing this great event. I regret very much that I couldn't have joined earlier, but personal family matters prevented me from doing so. But now I'm here. I see a lot of familiar faces and some unfamiliar faces, and I hope to have some more conversations maybe afterwards, relevant conversations, of course. Okay, this talk today, I would first like to start, no, that doesn't work, wait a second, by introducing myself. For those of you who don't know me, I would like to self-identify as a computational cognitive scientist with an eye towards higher order cognition, in particular language use. I would like to define the aim of my general research program as contributing to building conversational agents by understanding how language works in general, so theoretically informed by also empirical investigation, looking at how people use and interpret language in context, and to build models for both language production, generation, and interpretation, because I think these are tightly intertwined, using Bayesian models of cognition, that is explicit probabilistic modeling of the data generation process, that would be the utterance generation process, and the reception thereof by mimicking or simulating this utterance generation process. One of the things that are really crucial in my mind to understanding how people, agents, use language is relevance. And today I want to focus on this notion of relevance, which is highly elusive, extremely perplexing, but super fun and interesting. At least that's what I would like to convince you of. So let me start out by making a general case for the relevance of relevance in general in science. Like, at the first approximation, we might want to say that something X is relevant if it makes a difference. If it makes no difference, we can disregard it, it's irrelevant, right? But what exactly we mean by something being relevant is up for grabs. But let's make a few baby steps towards approaching this question. First of all, let's ask ourselves, what is X? What do we think are objects that we can attribute being relevant or not to? And first and foremost, there is something like information, questions, and representations. As an aside, you can also say that certain actors, organizations are relevant. You could say Extinction Rebellion is more relevant than Greenpeace. And we would know what you want to say, right? But that's kind of maybe almost, adapted use of being relevant that I want to bypass. Definitely information can be relevant. Think of Sherlock Holmes solving his cases by making astute observations about minute details that most natural observers would miss, but Sherlock, with his particular mind, immediately sees and is able to relate to the case at hand to draw interesting conclusions from that. So observations can be relevant. Your data can be relevant. You can have, if you work in a frequentist paradigm, you can have a data set that gives you a non-significant result. And so your data is irrelevant to saying anything sensible about the null hypothesis unless you use some power calculation pre-registered, or you should switch to a Bayesian analysis. Questions could be obviously relevant in some sense. Again, taking an example from statistics in optimal experiment design, we ask which experiment would give me on expectation more information about the issue that I'm interested in. So in a sense, this is like one layer of quantification over information of an observation. Like in expectation, what are the relevant information that I could expect to gain from all the possible outcomes of my experiment? Similarly, you could level this up and talk about the general relevance of whole research projects, of course. We can also talk about the relevance of representations and concepts. So for instance, here in a recent PhD thesis from Osnabrück, Viviane Clay had nice reinforcement learning agent simulations where agents run through a larger visually presented world and can interact with this world and have to figure out what they have to do. And what you see is that at a certain level of visualizing the content of the representations of the environment that these agents have accrued, these representations correspond to things that are action relevant for the task that the agent is trying to fulfill. Similarly, in statistics, you might compare different models, maybe for simplicity, different regression models with different types of factors trying to predict a certain outcome. And you might wonder whether a certain variable is actually relevant for making good predictions. Okay, just a few examples of different ways in which we can think of different items as being relevant. Another distinction we definitely have to make before we launch into the conversational aspects is that relevant information, concepts or whatever, can be relevant for different things. They can be relevant for your beliefs. If you only care about, having a good representation of the world, then information can be relevant for your beliefs and your beliefs only, to draw conclusions, etc. But they might also be relevant, or relevant in a different sense, if you want to act on them. Think of the last example, the conceptual representations of an agent who runs around a maze trying to collect stars are action relevance, or there's action relevance that is the key concept here. Whereas if you would want to make predictions, just predictions without actually acting on them, then in this maybe regression model example, then what you're optimizing for is something like epistemic relevance, just for your beliefs. And obviously, in the statistical literature and the decision theoretic literature, there's quite a lot of formal notions that have been suggested as formalizations of these different aspects of relevance. And we'll come back to this later. But now, something completely different. Here's your favorite idiot on the way to a family vacation. And 5 minutes after leaving home, Homer says, "I didn't turn off the stove." Happy as always. Semantically, that means that there exists a moment in the past at which Homer didn't turn off the stove. But obviously, what we understand this to mean is that this is not just an arbitrary point in the past, but something rather recent, namely a relevant point of time in the past where Homer forgot to turn off the stove, namely just about before leaving the house, and we should go back. Upshot of this example, there's a lot of underspecification in language that we have to fill in. You can think of this as, the semantic meaning, the actual meaning of what we say as containing holes. And a lot of these holes have to be filled in with additional information to be able to act on it, to respond to it fully, to understand what's being said. And relevance, in some sense or another, is a driving motor of how to fill in those gaps. Another example from language. This is from the movie Coffee and Cigarettes, if anybody knows, and these are two famous musicians, probably too old for you guys to appreciate. So one of these guys goes to the jukebox and checks it out and says, "There's none of your songs in the jukebox." Well, that's it. There's no holes to be filled here, right? But what is he actually trying to say? Both are musicians. There's none of your songs in the jukebox. Probably it's like a maybe camouflaged teasing insult, as in you're not a very popular musician, are you? Later, it turns out that there's also no sound of him in the jukebox, another issue. So what is this? In a sense, you understand the sentence perfectly without having to fill in the holes, but you still have to figure out what the point was that the speaker was trying to make. So two considerations of relevance, whatever that means, matter a lot to how we understand language and conversation. But if we now think about this in a schematic way, it's actually rather puzzling, because we might think that there's a speaker who produces utterance like he didn't turn off the stove or none of your songs are in the jukebox, and there's a listener who has to interpret these things. And if there is unclarity, theoretical unclarity about what relevance even means, is it relevant to the, right? It's kind of whose beliefs and action do we mean? The speaker, the hearer? Do we mean the conversation as a whole? Are we speaking just for the sake of conversation? Do we mean relevance for beliefs, relevance for actions? And then you have two agents actually having to reason about these aspects of relevance in order to be able to coordinate on a situational meaning. That situation looks pretty complex and convoluted in a sense. And I would like to try to get a little bit more clarity on this picture. How do we reason about what is relevant information, given that there's so many different senses of relevance and that there is maybe layers of uncertainty and theory of mind reasoning about what counts as relevant? I will not get to a full solution here, but there's a question which I may take right away. Oh. Yeah,
So let me make sure that nothing relevant is shielded from you.
That's okay.
Hello,
I
hello.
think that's maybe a little bit. I'm sorry.
Just
So I was wondering, how do you differentiate between relevance and implication here? Because like the second sentence especially seems more like the actual meaning is implied instead of the sentence itself being relevant or irrelevant.
You mean the none of your songs?
Yeah.
Well, implication can mean quite a lot of things.
Yeah.
Actually, if you just think about logical implication, every sentence logically implies infinitely many other sentences. We have to figure out which ones of those are the ones that are intended, which are the ones that are relevant to attend to. There's a paper by David Lewis, for instance, exactly about relevant implication. So just looking at implication doesn't help. You have to figure out which of the infinitely many implications you can draw from utterance are the relevant ones.
So, all right, I see. So the relevance is like a separate question from the implication. Or maybe I'm not quite certain how you mean relevance in this case.
Yeah, and I'm not sure what you mean with the implication.
All right. Okay.
So
yeah, maybe I'll understand better what you mean with relevance later.
let's come back to this question.
All right.
For sure. Thanks. All right. So what I would like to try to do today is actually poke around. Like I said, I don't have a full general solution to this big question or this problem set that I try to outline here. My goal would be for this talk to make you interested in this kind of setup of a problematic aspect about reasoning about relevance. And I would like to show you a few baby steps towards where we are. Of course, I will also mention as we go along that it's not the first time that people are started thinking about relevance in conversation, obviously. But my goal specifically, to be concrete and precise about this, is to use an empirically informed search for a quantitative measure of relevance, or several measures of relevance if there are several senses of relevance that are important for us. And I specifically want quantitative measures because I think of the end goal as also being able to build artificial agents in terms of them. So a quantitative measure would be useful to put in a utility function or a loss function for training an agent or for evaluating how the performance of an artificial agent is supposed to look like against human data, for instance. And therefore, I would like to draw on information and decision theory, and actually a long literature list from the past. So I'll drag you through 4 different case studies that all highlight different aspects of them. The first one is really just, oh no, I just need to say one thing. Is anybody here familiar with relevance theory? Okay, then I don't have to spend a lot of time arguing why I'll not spend time on relevance theory. It can be very short. Relevance theory is a hugely influential verbal theory from philosophy of language, but has also been very, very influential in anthropology and, you know, certain areas of cognitive science. And they make a lot of things really clear in language. But if my goal is to have quantitative measures of relevance that I can plug into, let's say, an NLP system, then it just doesn't help me if the definition of relevance is something like the greater the positive cognitive effects achieved by processing an input, the greater the relevance. And then there is not much more than that. There is more than that, but it doesn't get any more formal and definitely not quantitative. But since you've never heard of relevance theory, I don't have to defend myself too much about not going into detail about this. Rather, I'd like to show you a recent study with colleagues Hannah Rodi from Nijmegen, from Edinburgh, Getuk from Nijmegen, and Mayan Keshev from Amherst. It's a small paper that just is about to come out in Open Mind, and it's trying to establish that listeners indeed have rather peculiar expectations about the speaker's relevance, or what speakers should relevantly say. The paper goes like this. This is, in a sense, cashing in that this Homer Simpson intuition is also empirically vindicated. So suppose you have 2 sentences. Rebecca thinks that, or Rebecca announces to me that Liam has so and so many t-shirts. And you're supposed to guess which number of t-shirts is more likely to occur in one of those 2 sentences, right? So at each trial, you see Rebecca thinks that Liam has so and so many t-shirts, and you are asked, is it more likely 21 or 29? Why did we pick these numbers? We had a pre-test. We first elicited people's prior beliefs about how many t-shirts usually people own. And 21 is just about the mean of the ratings that we observe. And 29 is 1.5 standard deviations on top of that mean. So basically, if you read a sentence, somebody writes down, Rebecca thinks that Liam has so and so many shirts, right? What do you think is more likely number? That she thinks it's about the mean or 1.5 standard deviations above the mean. And when she say, when the sentence is, Rebecca announces to me, that's a speech, which number do you think is more probable? The mean or 1.5 standard deviations above the mean? And we asked this a number of people, looking at the frequency of responses, we see that people expect the higher number more strongly in the speech situation. What does it mean? It means, according to the interpretation that we would like to champion here, that speaking up increases the pressure of providing relevant information, because that somebody owns, you know, an exact average amount of t-shirts that what everybody would expect is not newsworthy enough to be able to speak up. Variation on this. Rebecca said when asked, still speaking up, but in a context where I had asked her, hey, how many t-shirts does Liam have? Against Rebecca said out of the blue. Similar picture. Speaking up out of the blue raises apparently higher expectations of relevance of information than providing this information when you were asked about. Though much smaller in contrast, still significant. Final a little contrast. Rebecca said to me versus Rebecca stood up and announced to everyone. Second also seems to have a higher expectation of informativity, unexpectedness of the information than the first one. upshot being here, this is like basically just vindicating the Homer example. Listeners seem to expect more newsworthy or relevant information in different kinds of contexts. That is, of course, if you believe that relevance has a role to play, which brings us to the question of what counts as relevant in information theoretic terms. Yes. Sorry,
Can you
repeat?
oh yeah.
Yeah. So I mean, this example really raised my curiosity of what is the controversial about a relevance theory. Could
The one that I
yeah.
introduced, which
Yeah, could you briefly
the
describe
one
it?
where I did not want you to think about.
Yes.
Maybe I can try to also address a bit this question of yours. So relevance theory is really trying to define relevance of an utterance, relevance of a stimulus, even just an observation, in terms of the number of implications that you can draw from them. But to me, that seems circular, because just logically, right, you have to refine this to then relevant implications, and then you have to define when an implication is relevant and when it is not. Moreover, there are cases where relevance theory is not careful enough, in my mind, to distinguish between what is relevant to the hearer, what's relevant to the speaker, and how they reason about each other's perspective of what counts as relevant, which is something that we'll see later on in some of the models that I'll present here. Finally, maybe also with respect to this implication thing, I can say in information theoretic terms, more on this in the next case study, why 29, given a certain prior distribution where 21 is the mean and 29 is 1.5 standard deviation away from it, why learning that, what's the guy's name, Liam, has 29 t-shirts is more surprising, given my prior beliefs, than learning that he has 21 t-shirts, right? And so it's more relevant information. And I'm not sure how to do this. It's usually a weak argument, right? But I'm not sure how to cash out this difference in terms of quantitative a priori expectations between different pieces of information in terms of the number of implications or anything else related to just qualitative implications that you can draw from. Maybe you'd have to say something like, then the relevant implication is that Liam is special and has more shirts than an average. But to me, it all seems convoluted in trying to save a dead horse, because you want to quantify the prior beliefs and go information theory. All right. Does that answer the question? There's another one.
Just a very brief follow-up question out of curiosity. Did you also try the reverse, as in the numbers were already filled in, but the people had to choose between the phrasing?
No.
I'm not sure if it would change anything, but sometimes there are like curious effects, right?
That's a good one. So nobody didn't test it. I have to think about what that would mean. It's a nice one. Maybe another one, Paula?
Yeah, I thought I'd get in line now that we're asking questions. So you said, or the theory is that the situation in which it is announced somehow relates to relevance, right? So
the context the context establishes different expectations of what would be relevant information.
exactly. Are there also theories about what exactly about the context it is? Like, is it like you had this example of stood up and announced to everyone, which is, I think, a greater step to take or more effort to put in. So is there some relation? Has this been asked whether the effort is kind of related to the relevance, like scales it up?
Yes and no. So I'm not sure what to say about this. So in relevance theory, there is a prominent proponent. His name is Tom Scott Phillips. So I'm sure if he's a proponent of relevance theory as such, but he's at least sympathetic. He has a paper called The Evolution of Relevance, in which he's trying to argue for basic principles of relevance theory being vindicated by an evolutionary model, which uses backward induction for a little games theoretic thing. I think that's completely wrong. It's the wrong way around. You need to use forward induction, a game theoretic solution concept that basically says what you need to do is you have to vindicate the effort invested on the speaker side by your expectations of relevance. So I would completely agree with what you just said. Just that you would have to flesh it out. I'm not sure of a model that does this in full generality. All right. Let me please try to go on, because I was maybe ambitiously hoping on presenting 4 case studies. So this one is actually much more relevant than the first. So let's rather sink our teeth in this. This is joint work with Omar Agar from NYU moving to UConn, and Alex Warstad also from NYU now moving to Zurich. The starting point of this study is another way of thinking about relevance of information, and it's called so-called QED theory. So according to QED theory, a proposition, and this is now all nice and set theoretic. This is a classical, logician style way of thinking about the relevance of information. You would say a proposition P, which you can think of as a set of possibilities, events, possible worlds, is relevant if P is at least a partial answer to a question under discussion. So in conversation, we try to answer questions under discussions, usually just one main one, maybe some side issues, but the question under discussion is what counts as relevant. So for instance, in the case of these 2 musicians, the question being answered or addressed, at least partially, is, are you a successful musician? And a proposition is relevant to this question if it eliminates cells from this partition. You can think of this as this is your question, which contains of different possibilities, and a resolving answer would leave you with just one cell. You know exactly what you want to know, no more uncertainty about the things that you care about. You could also get an answer that is a non-answer, which gives you some information, but none of which rules out one of the possibilities that you're really interested in sorting out. And you can also get a partial answer, which says, I can't give you a fully resolving answer, but I can give you at least a partial answer so that you can rule out some of the relevant distinctions that you're interested in. And relevance in this picture is defined just in terms of this partial answer. But then, as Omar and Alex have observed in a previous paper, this doesn't square well with our intuitions about relevance. So first of all, you can essentially introduce or give other kinds of answers that are relevant, even though they are not partial answers to your original question. So if you ask, John is going to Coachella, then your main interest is in finding out whether we are on the left or on the right. But if you answer or Lollapalooza, then you're basically introducing a new alternative here, and you're ruling out some information, but you're not actually telling me whether we live in the left or in the right type of possible world. So according to this previous definition, this would be irrelevant information. More importantly, for the future concerns, let's look at this final example. Will they cancel the picnic? So again, the question is about, do we live in the left type of world or situation or the right type of world or situation? And the answer would, it's kind of cloudy, doesn't answer this completely, but can still be considered to be kind of relevant information because it might shift your beliefs about how likely each of these cells is going to be the case. And this is exactly the sense in which I would like to probe further. So how do, maybe I should go back, how do different probabilistic and evidential statements count as relevant answers to a given question? Before doing this, make it even more complex, because there's at least 2 senses in which probabilistic or evidential information can be deemed relevant: on a first order level or on a second order level in terms of higher order uncertainty. Here's an example. Suppose we're debating how many balls are red in a big urn. And think of this as a huge urn, a lot of balls, so you can almost think of this as a coin flip. So the number of balls is sufficiently high that, you know, we don't have to worry too much about it. And we are unsure about the number of red balls. All the other balls are whatever blue, doesn't matter. And let's say initially you have no idea. You draw from this urn and you say, like, you observe that 2 are red in a draw of 3. Okay. Then maybe you could say, by maximum likely estimate, you think that the probability of the next draw being red after putting the balls back in, or the probability of or the proportion of red balls is roughly 2/3, or it is 2/3. For the sake of argument, assume that your prior beliefs are it's 2/3, right? But now imagine that in this context, I'm also telling you there are exactly 2 times as many red balls as blue balls. But it's exactly what you already believed a priori. But I have actually given you very much the information that we were looking for. What is happening here is that I have reduced your higher order uncertainty. Previously, the 2/3 was your best guess. But if I had given you $1,000 for guessing that it's 0.7, probably you would have accepted the $1,000 and went from your best guess 2/3 to 0.7 and earned some cash, right? But you wouldn't do that afterwards because I've reduced your higher order uncertainty about this estimate. And this is relevant information, though it hasn't changed at least your point level beliefs, your first order beliefs about the question under discussion. So schematically, and maybe for complete clarity, we look at first order beliefs. So you have a prior belief and you have a posterior belief. And for instance, in a yes/no question or polar question, a prior belief is completely specified by just one number, the probability of a yes answer, for instance. And your posterior belief would just be another number, the posterior of the yes answer. And relevance is some kind of function of the change from the first number to the second, for first order beliefs. For second order beliefs, the picture is more complicated. A higher order belief in the prior situation, and in the posterior also, could be something like a beta distribution, a distribution over probabilities of the yes answer. And incoming information might change your beliefs about this probability of the yes answer in certain ways. And so relevance could be a function of the change from one type of distribution to the other type of distribution. Candidate formal notions from information theory and Bayesianism, which is not the same thing, abound. And the most obvious ones for quantifying belief change going from a prior to a posterior, no matter whether it's first order or second order, all of these apply, can be given in terms of entropy change, Kohlberg-Leibler divergence, or Bayes factors. These are the most prominent ones. So entropy change, very roughly, just asks how much more or less certain are you after hearing the answer as compared to before hearing the answer. You might think that it's all just about reducing uncertainty, but sometimes getting information that you have been overconfident can also be relevant. So we are looking at entropy change in both directions. Kohlberg-Leibler divergence is another information theoretic concept, and there's different ways of interpreting this, but you can maybe roughly think of it as a means of quantifying how much excess. Think of it as a measure of divergence. You have your prior beliefs, and you shift to your posteriors, and when you look back from your posterior, you look at how wrong have I been before, given that what I now believe would be, if that was actually true, how wrong would I have been before? So you quantify, in a sense, how much have you learned in retrospect, looking back at where you came from. Finally, Bayes factors are a non-information theoretic, but Bayesian measure of observational relevance, actually. So here the story would be, you have your prior beliefs, you have your posterior beliefs, and you quantify the amount of observational information. Think of it in terms of coin flip outcomes or balls drawn from that urn, how many draws would I actually have to have made of the right kind to go from prior to posterior, right? And that is basically how much do I have to walk around the world, change my beliefs. And it's a different way of quantifying belief change. So what we want to do in this work is to give people in an experiment certain contexts. So is a wedding, main question is, will the ceremony be outdoors? And we'll give them an answer, like it's a beautiful sunny day, or another answer, there are supposed to be 100 guests. And essentially this is set up as follows. This context here will bias people, hopefully, in various ways. A negative bias gives you a prior bias towards a no answer of the relevant question. A positive one, a positive context gives you a prior bias to the yes answer. If everything's fine, neutral is in between. There's different types of answers according to our pre-classification. There's exhaustive answers that should just, settle the question for good and there's no more discussion. There's a high certainty answer making the yes answer very likely or the no one, depending on the answer polarity. There's a low certainty, it's just only weak evidence according to our pre-classification. And then there are non-answers which are completely irrelevant, at least according to our classification. All right. We have people read the context with the question. They don't get an answer yet. And this is to elicit their prior judgments. And we ask them, given the context, how likely do you think the yes answer is with a slider? This gives us information about their first order prior beliefs. We then ask, okay, given that you rated such and such with this slider, how committed are you to the probability being around this number that you chose? And they answer using a Likert scale, which we will use as information about their second order beliefs, their confidence about the prior judgment, the point judgment that they made before. After this, all the same participants, so sequentially going through this, they get an answer. Now Clara responds, there's a wedding canopy set up at the beach. And we again ask, no, how likely do you think the positive answer is now? So point estimate for the first order posterior belief. Same story, how confident are you? Information about the higher order posterior belief. Finally, after all this, we also ask the same participant for the same vignette, and how relevant do you think that answer was? So essentially, from each participant, we get data about their prior, their posterior, and their intuitive judgments of the relevance of this answer. And we can try to investigate, essentially, I'm skipping a lot of things here in the interest of time, how different information or Bayesian measures of potential measures of relevance correlate with the intuitive judgments of relevance of our participants. So on the x-axis, what you see here is the computed derived measures of relevance, entropy reduction, actually entropy change, Kalbach-Leibler or Bayes factor for the first order cases and the second order cases, plotted against the intuitive relevance judgments. And what you can see, at least from this clumsy picture here, is that the different notions do seem to make a difference. They are not all the same, and they're not all equally well correlated with the intuitive relevance judgments. So let's compare using statistical model comparison, how well each one of these individual factors that we could summon as possible notions of relevance of the participants. What you see here are two ways of comparing models. These are regression models with appropriate random effects, all with a single explanatory factor, but one's compared from an ex ante point of view and one's from an ex post point of view. if you're unfamiliar with this, maybe you come from an ML context, think about this in terms of cross validation. You do cross validation, you have a test set, and you have a training set. Usually your training set is maybe 60%, 70%, your test set is the rest, or maybe you have some validation set. And these are the extreme cases. The base vector ex ante is before everything. Everything is the test set. You're testing your model's predictions without training. That works for Bayesian contexts where you have reasonable priors or default priors. The other one, the ex post, is the other most extreme case of cross-validation, where you train on everything repeatedly, k-fold cross-validation. You train on everything except one observation. Leave one out, cross-validation. Okay, so you might want to say, maybe we do one more k-fold cross-validation in the middle, but these are the most extremes. And we ask which model with a single explanatory factor is best. And here we get a rather clear result. The base factor notion, or the base factor relevance measure at the first order beliefs is, given this data and this way of comparing models, the best predictor of the relevance judgments. So we'll stick with the base factor notion of relevance, and we'll look at another case study on argumentative language use. This is joint work with Chris Cummins, Edinburgh, and Fausto Carcassi in Tübingen, who is also present today. And if I misrepresent Fausto's views, he will tell us in the Q&A. It's very likely. So let's come back to the musician's case, right? Iggy Pop and Tom Waits debating who's a cool musician. Now I'm already setting up the stage of how I would like to analyze this case, because you have this. There's none of your songs in the jukebox, and you say, like, it kind of implicates something, right? It insinuates something like you're not a cool musician, and this can actually be expressed using this base factor notion of relevance, which is this evidence-based way of thinking about relevance. Think about it in this way. We'll define a notion of argumentative strength of a proposition, like there are none of your songs in the jukebox. And we immediately feel, and this is now how this works in particular is really difficult to pin down, but we immediately feel that this raises, you could say, the conclusion that I'm not successful, that the addressee is not a successful musician. And one reason why this could be, no matter what your prior beliefs are, this guy could have been completely confident that he's the coolest musician on earth, and still they feel that this is probably relevant or meant relevantly to a conclusion that I'm not cool. So we want to have a measure of relevance that maybe sidesteps looking at the priors of the agents, namely just by asking, does this proposition provide evidence in favor of a certain conclusion, no matter what you believe about it? And that's what you need the base factor for. So you have to reverse, and you have to say, an argument provides evidence in favor of a conclusion H or hypothesis H over an alternative hypothesis H, which usually is the negation, but doesn't have to be, if the likelihood of A being true under H is bigger than the likelihood of A being true under this alternative hypothesis. So think of this in terms of the musicians. So if you're an unpopular musician, it's more likely that there are no songs of yours in the jukebox than if you are a popular musician, no matter what you believe. And no matter whether these are both small probabilities anyway, because there are so many other artists that could be featured in the jukebox, this likelihood difference explains, so many people have argued, our feeling why this is an argument for such a conclusion. And maybe now we can think back about relevance implications. Relevant implications could now be quantified in terms of how much they change beliefs in exactly this way, no matter what the priors are. So this has been applied in a number of ways in quite different contexts. First in philosophy of language. This also has a very obviously in statistics. People have used it in theoretical linguistics, and also recently in more NLG natural language generation context. Yes. A what? The small a or the capital A? That's a proposition. That's the content. That's the content of the observation that you're judging for whether it's relevant. In this case, sorry? That is a shorthand for the sentence, there's none of your songs in the jukebox. I'm talking about this example. So let's see if this notion of argumentative relevance plays a role in the way in which people speak. Here's an experiment. There's a background story about some high school. Actually, there's 2 high schools, and you're supposed to look at the exam results from a particular exam from a high school, and your aim is to make one of those high schools look really good, like all the students did really well, like glass is half full, and another high school look bad, like glass is half empty, by choosing certain expressions. So for instance, participants see a display like that of 5 students, and for instance, Lisanne and Mia got quite a lot of questions right, and Julia, Teresa, and Julian less than these. And it's a very simple point and click experiment, and where participants complete sentences with just logical quantifiers of the form. In this exam, for instance, some of the students got most of the questions right. There's quite some variety of things that people can choose, and you can think of it, what is a true description of the situation? People were instructed not to lie, but also you can think about which one is a good description in order to make the exam result look positive or negative, right? And that's exactly what we were interested in. More concretely, we're interested in also modeling these choices using an extension of so-called rational speech act framework. That is a way of modeling probabilistic utterance choices and interpretations using some kind of approximate best choice probabilistic decision theoretic approach. In these approaches, what we usually do is we say that the utterance choice of a speaker given a state, or a state is a description of the world, like maybe this table that you've seen, and the utterance would be one of the selections that you can make, is proportional to softmax of some utility function. And in the utility function, that's where the interesting stuff happens. Normally, this kind of model would have factors for saying, okay, people want to speak truthfully. They want to minimize effort, but they also want to increase the informativity of what they say. Just being most informative, maybe even in a logical sense. But what's new in this model is that we also add a term for the argumentative strength, defined, as I said before, of the utterance, with the goal of making the exam look easy or more complex. I can tell you exactly how we instantiated this later on. We used a prior, so we used a Bayesian analysis for this, putting priors over the model's parameters, which is the softmax alpha, this linear combination parameter beta, and we also had a cost for negative terms, which we know from prior research are rather disfavored in these kinds of selection tasks. The important conclusion that we need to draw from this is that by just posterior inference over the relevant beta parameter, this is the linear combination parameter as that weighs informativity and argumentativity, we see that this is not equal to 1, incredibly not equal to 1. So the argumentative dimension did play a role in the way in which people chose their expression. The overall correlation of this model is decent, and in model comparison with the baseline model, we found that using the argumentative strength as a part of the utility function, quantitative argumentative strength as part of the utility function for predicting what people would say, was highly relevant in this model comparison sense. So again, Bayes factors came out as something like maybe the best explanation for people's intuitive understanding of relevance in the previous experiment. Here we use Bayes factors as the quantitative notions of argumentative strength to explain how people tweak the choices of expression in such a way as to frame a situation as positive or negative in some sense. Let me finish with the last case study, which is also the most complicated, but maybe also the most telling for this really big problem of reasoning about relevance. This is joint work with Robert Hawkins, Princeton, and Noah Goodman, Stanford. And here we're going to switch from talking about information theoretic or epistemic relevance to action relevance. Let me start with a simple motivating example. So suppose you're a bartender in a hotel bar, and what you currently have is very limited, because this is, again, another experiment. You have whiskey, you have beer, you have red wine, you have soft drinks, and coffee. Late at night, the woman walks in, she asks, do you have white wine? Now, quick check against what you have. You don't have white wine. So just make sure that you're still awake. What would you answer if you were the bartender? What you have is whiskey, beer, red wine, soft drinks, and coffee. Question is, do you have white wine? Yes.
No, but we have red wine.
So no, but we have red wine. Thanks a lot. That's also what I think most people would do, what I would do. But let's pause for a second and think what's going on here, right? There are different types of drinks, you could say. Here, there's whiskey and beer and red wine. They're all alcoholic beverages. I mean, it's a polar question. It's yes or no. But how people list it? Sometimes people exclusively listed things from the other category, thank God for that. And sometimes people were very exhaustive, but this may have been for cases where they weren't maybe sure about what's relevant. There was an item, for instance, about musical taste, and somebody asked, do you have bebop? And I think many people didn't even know what bebop is and just listed all the available genres. Anyway, but we also tried this out for more or less for fun with a version of GTP3, namely OpenAI's Da Vinci. And we did this once with prompting and without prompting. If you're familiar with this, GTP3 is a large language model that has been trained also on a lot of user data, which with the intention of making it sort of a very useful and easily programmable interface. So based on the kind of user queries that people gave over the first 8 to 12 months, I'm not sure, this GTP3 version was updated. And so you can very quickly tell GTP3 what the task is and coerce it to do. That's almost a few short learning, give a few examples, and it gets a lot of things remarkably right. So we were interested in how well can it do on these types of sentence completion tasks. And the upshot is it's not very good without any prompt, and it doesn't get much better with prompting. So GTP3 is usually quite happy to just say no. No, I don't care. Or list everything, which is maybe from a point of view of, pattern completion, not very surprising. But let's have a look at what's going on for humans. What's allegedly definitely not going on for a simple language model that doesn't have this pragmatic task in the back of its design. There's a questioner and there's a respondent. So previously I said there's a speaker and then there's a listener, and the speaker has to reason about what the speaker said. That's easy. But if you have reasoning about questions and answers, that's actually much more complicated, because in a sense, you have two agents that are both a speaker and the listener at different points in time. The questioner might want to reason about what question they're supposed to say, that's the production part, but also how that question is interpreted. A good question is one that is likely to give me the answer that I like, or not like, but the ones that I need. And the decision problem of the respondent, or the choice problem of the respondent, is more like which answer should I produce, but also why was this question? If we now think back, let me go back for a moment, to just big collective we, is we're trying to anchor this recursive reasoning or this step-by-step reasoning at an agent who is like encoding the dummy semantics, what we know about the language, but we don't want to give this agent any kind of insights into the specific of the context. So this first anchoring level of inference is context independent. And what does it mean to give context-independent answers to yes or no questions? It means that you can be confident at answering just yes and no if you know the truth. And if you know the truth, you can also give over-specific answers in the positive case. Imagine, Michael, do you have A or B? I know nothing about the context. I will not reason about what you probably want. If I know that I have A, I can say, yes, I have A. And I don't have to reason about your preferences. You asked for A or B. But if I don't have A or B, and you ask, do you have A or B, whether I should recommend C or D, I don't know. I would have to ask, I would have to reason about the context and the larger preferences that you might have. So this base level respondent is designed to give over-informative answers in the yes case, otherwise and always respond truthfully, but in the negative case to only give a simple taciturn no answer. The pragmatic questioner is picking questions that are most likely to give them the most relevant information, more on this in a moment, given this type of base level respondent behavior or answer behavior. And a pragmatic respondent who can reason about the reasons why the questioner chose a particular question, having in mind a rather simplified and decontextualized answer model, can then be able to deduce preferences from the question asked and possibly give over-specific answers. So more concretely, maybe just zooming in on the relevant bit here, which is the notion of relevance, we formalize the base level respondent in the way I've just described. There's actually a notion from inquisitive semantics, theoretical linguistics, that's called safe response, and that gives us exactly this kind of answer behavior. So you can say this is also vindicated elsewhere in the literature for whatever that means. But then most importantly, look at this pragmatic question. What this guy is doing is softmax choosing a question based on a utility function. It's long and complex, but essentially what you have is an expectation about which possible world is likely. What is the likely response that I would get given a particular possible world from this type of answering agent? And then here, how valuable, this is the value of in the updated decision problem with the response. What does that mean? You have a decision problem which includes your preferences and beliefs. You think about, if I ask that question, how likely is it that I'll get a particular answer back from this agent model that I have in mind? If I then update my beliefs in my decision problem with this response, how much utility will I get when I act as a softmax rational agent? The higher the utility will become by different answers, the better the question is for me. And so this is, again, from here, statistical decision theory, a value, this is called the value of sample information, and it's a decision theoretic notion of relevance, which we couch in here in a probabilistic question choice model. And similarly, we can then have a pragmatic answerer, which also tries to choose an answer by soft-maxing some expected utility, which is again defined as a combination of informativity, KL divergence between their beliefs. So you don't want to tell them just any kind of nonsense that just makes them do the right thing. You want to stick to the truth, but you also want to give them information that is actually useful to them, practically useful, given the preferences that you have inferred. So we ran a little prior elicitation experiment. We actually wanted to know, if you know that a person likes X, like white wine, how likely is it that they also like red wine, beer, coffee, etc.? We had this slider-based measure here, no change at all in the middle, and then left and right for it's much more likely or much less likely. And we used this information to specify prior beliefs about relevant preference structures that were specified as classical Savage decision problems, details omitted for time. And based on these empirically informed prior distributions that we fed into the model, eliciting prior predictions of the model. So this is not full-fledged posterior data analysis yet, still coming. We are able to generate a very similar, at least ordinarily, very similar pattern to what we see in the human data with this model, unlike, for instance, naive GTP3. So upshot of the whole thing. I think relevance is relevant in a number of ways, and particularly relevant for communication. If we want to design pragmatic agents, conversational agents, think about the cases where they're most often used. You know, simple question and answer bots, telephone hotlines, etc. Recognizing why a particular question was asked or why a particular statement was used. In terms of why it is relevant, it seems absolutely super crucial and important. You will be able to come up with, let's say, very situated and ad hoc solutions for many different cases, for sure. The more specific your use case, the easier it will become. But that doesn't dispense with the need to get a better understanding of what counts as relevant information in dialogue. Interestingly, maybe because of the elusiveness of the concept, there's been rather little work, especially rather little empirical work that is dedicated first and foremostly at coming to understand what people consider as relevant information in a given context. So I think that relevance is multifaceted, epistemic decision theory. Maybe there's even more senses that I haven't talked about, but maybe I can give you an example of what that is, just to blow your mind that it's even more complex than this. So you say, where is John? And your answer is Bill would know. Doesn't change your beliefs at all, doesn't tell you anything, but might put you in a position to find out. So it's relevance by enabling. And conversationalists must reason about all these facets of relevance. And ideally, we would like to have quantitative measures that we can actually use for training, for evaluation, etc. All right, I'll leave it at that. Thanks already for the questions, and maybe thanks for your attention and some more questions that I'll receive. Thanks.
Hi. So my answer is about the my question is about the Q&A rational speech act model that you were showing before. So maybe if you could go back a few slides. Exactly. So what is your utility function here?
For the pragmatic questioner or for the answerer?
For the pragmatic answerer.
It's actually defined here. It's much more complex than fit
Ah.
on slide. So I've cut a lot of corners here, but can you elaborate which aspects shall I try to
No,
talk to?
I didn't see it on the slide, sorry,
Okay.
but okay, thanks.
Shall I give you the intuition?
Yeah, that would be nice.
Right? So it's again a softmax. So it's an approximate approximating the following expected utility. So the expectations is in terms of your beliefs about decision problems. A decision problem is modeled here as a set of world state and a set of actions, a probability distribution over the world states, and a utility function that assigns a number to each pair of world state and action. So basically, how good it is for me to order red wine when in fact you don't have it, how good is it for me to order it when in fact you have it, etc. What we implemented here is, what is happening here is that this pragmatic answerer actually uses Bayes inference over a prior over potential preferences. The priors were constrained by the data from this experiment in order to find out what likely decision problems would have generated the answer that you've observed. In which decision problems would a pragmatic questioner actually have used this question? And then based on these posterior beliefs about likely beliefs and preferences, so this also works for belief inference. I haven't talked about this at all, but this model makes predictions about what is the most likely belief state of a guy who asks such and such. So based on your posteriors about the decision problem derived from observing the answer, you ask what is a good response for this decision problem. So it's all weighted with your beliefs, of course. And a good response given a decision problem when you fix it is one in which first the response, so the questioner's beliefs after receiving this response will get as similar as possible to your own. So minimizing the divergence between what you believe about the world states to what the recipient receives about the world states after receiving your answer, and about how well off the recipient is in making a decision in this decision problem after they have received the answer. So I'll give them the answer, they'll update their beliefs, and then they'll use softmax rational choice to choose an action based on their beliefs and preferences. How good is that for them? The expected value of this decision problem. It's the overall expected utility that you expect from your policy, your beliefs, and your preferences. And the cost of the response. Why the cost of the response? And actually the cost of the response also plays in the choice of the question. If you walk into a Chinese restaurant that has 200 variation on 300 dishes with all sorts of different combinations of sauces, you don't ask, what do you have, and hope for an exhaustive answer. So also to make sure that, you know, in certain cases, you will play more strategic and ask for certain aspects of information rather than the full list. You also have to take in the cost. It's rather complex, of course, but many things come into this. A bit better?
Thanks.
I have sort of a naive question to ask. So it seems like in a lot of your experiments, the options that are presented are limited.
Yeah.
And in real world situations, that typically is not the
That's
case.
totally correct.
But what does limit our options is the understanding of the context. So let's say if a woman comes up to me on the street and as I'm standing there and asks me, do you have white wine? I'll be like, no, and walk away. How important do you think that is for, let's say, like GPT-3 to understand in order to provide an answer or a question that's relevant?
Yes, a context model is super important, I think. And we do get a lot of this information. Maybe we do get a lot of information also from a short description of the context, etc. But I think there were two questions here, right?
Yeah,
I'm not entirely sure. I don't think it's naive. I think it's spot on. It's a very relevant set of questions. So first of all, a good contextual representation is absolute tantamount. And you correctly observed that all of these, the data that I presented here today were all on very limited choice situations, where we finally curate the choice option that people have. And that's a shortcoming. We're working towards generalizing this. Other people have done this too. Maybe basically the idea is you use essentially you would use utility functions like these, but then maybe in a neural language generation, neural language interpretation task, more generation so far, right? So this is work that's ongoing. This is where we are at right now. But the main point that I would really see in what you just said is relevance of representations. Remember, I started out relevance of information. I talked about it. Relevance of question. I talked about it. I didn't talk about relevance of representation. And that's exactly what comes in. So I think ideally what we want or what we should need is something like we construct a context model of relevant alternatives. And linguists talk about this a lot, but they have a more structural approach to it. What are alternatives to a sentence? Well, we need to have that in a context-dependent fashion. Like you are on the street, a woman walks up and asks for white wine, you walk away. No, you don't. You're in Berlin, totally normal, right? It depends on what context you are in and what kinds of alternatives you would then construct. So the way I'm seeing this is that we have probably evolved this as human agents, going from context to context, a way of maybe sampling or constructing relevant context representations of the options and possibilities that we do actually have to reason about, even if that reasoning then is still unconscious. If you wanted to, if I had to model this, I mean, it's easy to write down mathematically. It's really hairy if you have to fill it in with actual context, but you would have a context model generation function in the beginning. And that whole thing that is formalized here is then just one reasoning step for one context model, one set of priors, one set of alternatives, and so on. So relevance of representations, something I think we should work on.
Thank you.
Thanks a lot for the talk. I have another question. To what extent is the assumption of cooperativity of the two agents important here? Like, would this also hold if we assume different situations where for instance, the answer is actually not trying to be as informative as possible, but rather lying or something like that?
I don't think I understand the question. So what kind of context?
So maybe I can phrase this more generally. How do you think that there is one general notion of relevance for both cooperative and non-cooperative situations, or do you think there is a fundamental difference?
Okay, that's good that I clarified. I wasn't sure. You want to talk about potentially non-cooperative or not fully aligned preference structures between speaker and listener. And obviously then relevance really goes apart. Speaker relevance may be other than hearer relevance, and I don't know, but let me speculate nonetheless. I would imagine that we don't have ready-made a different arsenal of notions that we use to guide our decision-making for the uncooperative case. I mean, the fact that we can mislead people or the fact that we so often trust people probably means that we get along quite well with a good set of heuristics, you know, something that we would model as measures of how good an alternative and interpretation or choice of words is, etc., for the cooperative cases. And the uncooperative cases come in as hijacking exactly those notions. And we can try to outsmart other people in reasoning about why they didn't say anything smarter. So for instance, in these there's weak praise effects or weak evidence effects. You know, classical example by Grice. Would you recommend the student? He has beautiful handwriting. If that's the best thing you can say about this student, probably means it's not very good, but you still recognize he has good handwriting actually as a positive argument in favor of it. Think none of your songs are there, right? If the student, it's a sign of quality nonetheless. But then on the next level of reasoning, you would realize, well, is that the best thing you can say? So if I had to bet, I hope I don't, I would say there's just one set of, you know, relevance measures for the cooperative case, and the rest is abusing them and probably trying to be plausibly deniable in your abuse.
Okay, thanks. Yeah, I would have also a more general question, which is, you presented the human data and also the goal to implement this in conversational agents. And I was wondering whether, or maybe your opinion on I mean, this implies that, oh, sorry, this implies that conversational agents should act in a human-like way somehow. And maybe I was wondering whether you can elaborate on why you think conversational agents should act in a human-like way, or what could be.
Thanks, that's a really, really good question. Actually, first and foremost, I would think that conversational agents, even if they don't act in a human, maybe that comes down to the same thing. First of all, I thought you would want to say that agents should understand why human agents behave the way they do in order to do better whatever the artificial agent is trying to do. Of course, then for the human user, right, on the assumption that we as humans usually react well to our inferences about the intentions and preferences of the interlocutor, this would boil down to the artificial agent also doing things like humans do. But first and foremost, it would be more like intention recognition, reasoning about preferences in terms of what is relevant. But yes, I think, so the second part of the question was, can you repeat, why would I think that it's good?
Yeah.
Why would you not think it is good?
Yeah, I guess conversation might also get more complex, and sometimes also misunderstandings happen between humans. And if we would have conversational agents which just would answer something like, no, we don't, then we as humans could still infer or have the right answer to what we wanted to know, but we wouldn't have to like reason about what the conversational agent now wanted to imply with that, something like that.
So you mean we would first have to establish trust in the fact that the agents actually are reliable as human, like humans would be in what they don't say?
Yes, probably.
That's a good point. That's right. I mean, I'm asking back, it's a bit nasty strategy, but because I think that this issue is, again, so multifaceted also because, of AI threats, being manipulated by AI. So there's all these aspects. Well, actually, I say I would like to build artificial agents doesn't necessarily mean that they all have to be implemented. I think, like, even in a sense, these mathematical definitions are building an agent. Right? And you can squeeze predictions from this. And so one of these, just to be sure, one of these aspects here for me, at least, this what drives me, is understanding how conversations work, how dialogue works. Also maybe in a political spectrum, why sometimes certain remarks are perceived of as arguments but fly under the radar, how insinuation works, and and I think coming to grips with these agent models, even if they look rather complicated, also helps us see through certain conversational strategies of human agents.
Thanks. Do you still want to?
I'm still a bit hung up about the musician sentence earlier, because maybe it's just a limitation of my understanding of the model you're describing or the idea in general. But what I see with this example of the musician, or maybe with other examples more, is a kind of substitution of statements. So one statement is said and a different statement is intended. And like, I don't quite see how this is really handled by this model of relevance. It's more a kind of learned, like insinuation is what you said earlier. The term maybe is better than implication, what I said earlier. So would you say that this can be modeled as well with this kind of idea?
I hope.
All right.
So so let's take the musicians again. There's none of your songs in the jukebox. Then you might not know which other proposition, which goal proposition H, this is evidence for. And you have that, you could have that a lot with statements. I'm going outside, okay. I'm going to smoke a cigarette, all right. It's a Marlboro Light, Okay, why are you telling me this? What is the relevance of this? So maybe in many cases you are able to conjure relevance of interpretation, the right question under discussion or goal proposition that the statement you just made provides evidence for in this technical sense. And you can model this, but in order to do that, like I only use this so far from the speaker perspective. On the next level, you have a listener who hears none of your, just like here, this agent doesn't know the decision problem. In this other case, it would be this agent doesn't know what the goal proposition H is, but the reason about which goal proposition H would be such that it would have been relevant for a speaker to say if they wanted to argue for that. And then they might, this is an open-ended search, again, relevance of representation, but they might come up with the conclusion that this guy is trying to insult me.
But isn't it in like a very complex case with like the musicians? Like it's not like, not that I don't think you can model this with this system, but rather maybe that this would get way too complex to do in such a short time. So I'd expect there to develop some shortcuts. Like this, like if you hear this
as it's formulated here is way too much. Let's say, okay, let's bypass the musician's case.
Yeah.
This no but red, like we have white wine, no but red, that is something that we all immediately did, right? And I'm really happy to accept in this case that we don't go through any explicit, like consciously explicit calculations that amount to something like this. I hope you didn't. Otherwise, I would like to talk to you more. So yes, there's that. With the case of with the musicians, I'm actually not so sure. I don't think that's not complicated at all. You're just asking for the motivation, for the state of mind that's just one step. What state of mind would have likely triggered this utterance? That's what we do routinely. The miracle is in the fact that we can quickly hone in on the relevant set of possibilities. But that's what we do everywhere. That's what we do in memory. That's what we do at all levels. Right? We conjure. Well, okay, I have nothing to. That's what I say. I think that's the key next step is to look at the relevance of the conjured ingredients to these reasoning problems. But suppose you would be able to say, I can come up with 1, 2, 3, 4, 5 possible points the speaker could have made with none of your songs are in the jukebox. Then this reasoning is really simple. Just asking for which ones is this the most relevant insinuating statement, which at the same time maximizes the likelihood that I perceive it as an insult and being still plausibly deniable as an insult. Well, I didn't want to say you're not good. I just wanted to share some information about the jukebox.
All right, thank you.
Hi, I was wondering how you would give the context information explicitly, like without, like in case of few shot learning, it will take implicitly the context based on the conversation. So like, how would you rather give it like explicitly, say in this context, the menu would be an explicit information of context.
How do I do that?
Yeah.
Like how we actually do it?
Yes, yeah.
In terms of, for instance, here it's an optimization problem over the set of responses.
Mm-hmm.
And the set of responses here consists of just saying no, just saying yes, and then listing any or no, and then listing any subset of items that are on the menu, and this is a predefined list. So basically, right, and then there's 6 items, and you can
Yeah, got it.
Enumeration in this case. But I think it's clear to see how, in this case, with some measure of similarity, word-vec, how you could generalize this to a larger context. Thank you very much.
So yeah, let's thank our speaker again.